Hey guys, so in this video we're going to be looking at exact values for trigonometric functions. So these are the exact values you need to memorize when you don't have a calculator. So you don't have your calculator, so that means you need to know these exact values. So you need to know what, for example, sine 30 degrees is, etc. Now due to symmetry properties, which we'll talk about later, you don't need to memorize all of them up to, let's say, sine 150 degrees, because once you know between the main ones between 0 to 90, you can use symmetry properties to work out the others, which will make more sense when we go through it. But the ones you do need to know are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And that's the degrees, and then radians: 0, pi on 6, pi on 4, pi on 3, and then pi on 2. And as I said, with other ones such as sine 150, sine 180, we can use symmetry properties to calculate the values. So how do we know what these values are? So there are multiple ways of going about calculating them, but one of them is using sort of these basic triangles, or when I say basic, standard triangles, which can then tell you what the values are. So if we have a right angle triangle here, and then we draw it out so that there's 60 degrees, 30 degrees, 2, 1, and root 3. And you can check that the 1, root 3, and therefore the hypotenuse is 2. So if you memorize this triangle, then you can work out what the sine 30 degrees and sine 60 degrees are. So if you look at this, we can go, well, sine 30 degrees is equal to opposite over hypotenuse, which is equal to 1 on 2. Then sine 60 degrees is equal to opposite over hypotenuse, so opposite over hypotenuse, so root 3 on 2. So also note that root 3 is less than 2. But yeah, root 3 on 2. Then if we wanted to look at cos, we can go cos 30 degrees is equal to adjacent over hypotenuse. So adjacent over hypotenuse, so we get root 3 on 2. And then cos 60 degrees is equal to adjacent over hypotenuse, which is equal to 1 on 2. So you should be able to see that these actually relate to each other. And that's because sine 30 degrees is equal to cos 60 degrees. So sine 30 degrees is equal to cos 60. And we'll show that just using the unit circle. So if we have, let's say, unit circle here, and we take 30 degrees and 30 degrees, then this length here, let's call it x, will equal this length here, which is x, and this length here, which is a, will equal this length here, which is a. Now x, when we're talking about 30 degrees, this is cos 30 degrees. So cos 30 degrees is equal to x. Now, this is 30 degrees for this angle, but this actual angle compared to the x-axis is 60 degrees. So here is 60 degrees. So that means when we're talking about this length here, that sine 60 degrees is equal to x, because it's the same length. And then we can work out the other way, that sine, when cos 60 degrees is equal to a, and then sine, let's write it out, sine 30 degrees is equal to a, as we can see here, and then cos 60 degrees is that value up here, which is also equal to a. So you can see how these are equal. Then going back to here, you can see how this relates. So sine 30 degrees is 1 on 2, and then cos 60 degrees is also 1 on 2, and they're equal. So in general, for the first quadrant, we can say that cos theta is equal to sine 90 minus theta. And that is a useful thing to memorize, and you can also put it the other way around, that sine theta is equal to cos 90 minus theta. And that's because of this unit circle properties which we saw before. Now, if you're not sure which one sort of goes first, and if you're not going to sort of memorize this triangle, a good way to think about it is that, referring back to the unit circle, so if we have a circle here, and then we're going to be looking at cos at a particular angle, then this is equal to cos. As we increase the angle, you can see that cos decreases. So every time we increase the angle, cos decreases until it reaches a point 0. So that means cos 30 degrees will be greater than cos 60 degrees. So cos 30 is root 3 on 2, and cos 60 is 1 on 2. Then if we looked at sine, so instead of looking at cos, we now look at sine, we can see that when it's really small, when the angle's small, it's small. But as the angle gets bigger, it gets bigger. So we're looking at the opposite side now, until it reaches a point 1. So that means sine 60 is going to be greater than sine 30. And now we know that 30 and 60, sine 30 is equal to cos 60. So we can think that, well, sine 30 degrees and cos 30 degrees, they either have to be root 3 on 2 or 1 on 2. And I know that cos 30 degrees has to be the bigger one. So cos 30 degrees is equal to root 3 on 2. Then sine 30 degrees is equal to a half. Then when you think about sine 60 and cos 60, you know that it has to be, once again, 1 on 2 or root 3 on 2. Now sine 60 is bigger than cos 60, so sine 60 has to be root 3 on 2, then cos 60 has to be a half. But what about if we look at the 45 degrees? So if we now want to look at 45 degrees, we can use a similar thing where we create a triangle. This time it's a different triangle though. Here we have 45 degrees and 45 degrees. Then we have here, which is the sides are 1, 1, therefore the hypotenuse is going to be 1 squared plus 1 squared, which is 2, square rooted, so square root 2. And from this we can work out the different values. So sine 45 degrees is going to equal, so let's say we're looking at this angle, it's going to equal the opposite over hypotenuse. So it's going to be opposite over hypotenuse. So it's going to give us a value of 1 on root 2. Now I can simplify this, and the way we simplify this with the square root is by timesing it by the same value to get rid of the square root, and that's this root 2 on root 2 is just 1, so you can just times by 1, and that will give us root 2 on 2. And that's the main reason you do that, is to move the square root from the denominator to the numerator. So we see that sine 45 degrees is equal to that. So what about cos? So if we look here, cos 45 degrees is equal to adjacent over hypotenuse. This is equal to 1 over root 2. So it's the exact same value, and that is equal to root 2 on 2. So sine 45 and cos 45 degrees are equal. And this makes sense, because if we have, let's say, a line there, and this value here is equal to 45 degrees, let's say this was the unit circle or anything like that, we took that point down, we made it a right angle, then both these values here are going to be equal. So if this value is x and this value is x, then they're going to be the same. And that's because 45 degrees is when you have the gradient is equal to 1. So every time it goes across 1, it goes up the same amount. So no matter how long how far across you go, then you'll go up the same distance. So that's why sine 45 degrees is equal to cos 45 degrees. This also relates to the formula we just looked at before, when, let's say, like sine theta is equal to cos theta pi on 2 minus theta. So that's 90 degrees. So when theta is equal to 45 degrees, then this is equal, then you can sub these in, and you see that 45 is equal to cos 90. So this is 90 minus 45, so we get 45 degrees. So that's obviously radians, that's degrees, but you could have said here 90, or you could have left that as pi on 2, and then you could have said 45 is equal to pi on 4, and then the formula still works out. So the main thing to do is you need to memorize this number here, or these two are equal, and then you know what cos 45 is, therefore you know what sine 45 is. So looking at tan. So tan theta is equal to sine theta on cos theta. And because we know what sine theta is and cos theta is, we can sub those values in and then we can work out what tan theta is. However, takes quite a bit of time, so I think it's just best to memorize the different values. However, if you ever get stuck, you can just remember what sine theta is, what cos theta is, sub those values in, and then you can work out what it is. Or you can use those triangles we had before. So if you remember, we had this triangle, then we had like 60 degrees. And once again, you can work out what it is by using the fact that tan theta is equal to opposite over adjacent. So you can do those methods, and if that works for you, you find that you don't make any mistakes using those triangles, you've already memorized them, that's really good, you can do that. However, with tan theta, I like to think about it as has lots of like root 3's, and using this, you can memorize the 3 different values. So you have 3 different values. You have root 3 on 1, root 3 on root 3, and 1 on root 3. And these are the 3 different values which tan theta is equal to, for theta is equal to 30, 45, and 60. So this is equal to root 3, because root 3 on 1 is just root 3, root 3 on root 3 is 1, and then 1 on root 3 is 1 on root 3, or root 3 on 3. So these are the 3 different values. So firstly, looking at tan 45 degrees. Well, tan 45 degrees is equal to sine theta and cos theta. And we know that sine 45 and cos 45 are equal. So any value over itself is just 1, because you're dividing by the same amount. And because of this, tan 45 degrees is equal to 1. So that's the first value here. So tan 45 degrees is equal to 1. Then what about if we now look at tan 30 degrees? Well, if we're looking at tan 30, we have to think, is sine 30 large or small? Well, sine 30 is quite small. And then cos 30 is quite large. So when the numerator is quite small and the denominator is quite large, we're going to get a small value. So therefore, tan 30 is going to be the smallest one of these 3. So it's going to be 1 on root 3. Then what about tan 60? Well, tan 60, sine 60 is relatively large, and cos 60 is relatively small. So when the numerator is relatively large and the denominator is relatively small, we're going to get a large value. So that is equal to root 3. So then we can see that the angle 30 is equal to here, and 60 is equal to over here. And once you do it a few times and you start to get used to these values, it becomes a lot easier. But as I said before, if you want to use the triangles as we mentioned earlier in the video, then you can still get the right answer. In summary, here is a table of all the different exact values. So I didn't talk about all the different values, such as 0 degrees and 90 degrees. However, I talked about them in previous videos. But if you don't know those, just make sure you memorize them as well. So here's 30 degrees, 45, 60 degrees, and there's a sine, cos, and tan. And also remember that this, in regards to radians, that'd be 0, pi on 6, pi on 4, pi on 3, then pi on 2.